Hi everyone, welcome to our virtual lunch and learn for June. My name's Mark Foer and I'm a client engagement principal and machine learning practice leader here at DiUS. Before we begin, I'd like to acknowledge the traditional custodians of the lands that we are meeting here today. I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Australia. I also acknowledge and pay my respects to any Aboriginal and Torres Strait Islander people and colleagues joining us on the call today. Again, my name's Mark. I'll be providing a quick introduction to DiUS before we hear from our speakers, Tom Wall, Experience Design Principal, and Shahin Namin, one of our machine learning specialists. Now, for some quick housekeeping, we'll be answering questions at the end of today's presentation, and we'll be using Slido, so please feel free to enter them as we go. There'll be a link posted on the chat. If you would like to turn on captions, you can do so by clicking on the three dots on the bottom of the screen and selecting captions. And we'll be recording this session, so we'll make this available to you for future viewing and to share with your colleagues. Firstly, only a quick introduction. As many of you already know us, we're an Australian technology consulting company. We have roughly 150 people, I should say, across Australia and APAC, from engineers and technical folks to delivery leads, QAs, experienced designers, etc., which allows us to form cross-functional teams when solving customer problems. DiUS is quite unique in that we have deep in-house expertise across digital data and devices, which includes web and cloud, machine learning and IoT, how to bring it all together from running experiments right through to the rigor required for production. And we do all of that with experienced design at the heart of it all. And the reason why we have Tom here presenting along with Shahin. In addition to our core consulting business, we also build our own products, two of which are powered by machine learning in some form. Today's talk is the latest in our machine learning series. For those who have been following us, you would have heard us speak about machine learning application areas such as computer vision and how it's being used in the field, data readiness for machine learning, how to get machine learning models into production and other related topics. This talk is focused on how you can use machine learning to build products to create better customer experiences and provide a competitive advantage. So why this topic? Last year, we surveyed 200 organizations in Australia to understand their challenges and priorities for machine learning. What we found was for those already applying machine learning, operational efficiency was the most common reason or driver for adoption at 48%. Whilst 35% were using machine learning to improve customer experience. This was pretty much in line with our commercial experience. Organizations have initially taken an internal focus, looking to apply machine learning in areas that might be labor intensive, repetitive or error prone, and looking for ways to augment tasks, improve the process or better support decision making. When we asked about their future plans, operational efficiency remains high, but there was a notable increase in customer experience from 38% to 47%. Again, in our commercial experience, we have also observed this. There is a growing number of machine learning powered digital products that either improve or create brand new customer experiences. We're seeing many startups where ML is core to the product idea, so they're using machine learning from the outset, and we're seeing this across almost all domains, including healthcare and fintech. And even for more established businesses, we're seeing organizations starting to inject machine learning into their product experiences. And on that note, I'll pass over to Tom.
Thank you, Mark. I'm just going to do the shuffle. Okay, cool. So as Mark said, I'm a principal on the experience design team at DiUS. We are a small but mighty team. We are completely outnumbered by engineers, but I like to think we have some big impact. I think key to our approach at DiUS is that cross-functional approach. You know, we don't like to think about sort of just the tech or the product, you know, the business need or the human need to the exclusion of all. It's thinking across all those three layers. You know, the experience, the business value, as well as the being able to achieve the solution. I guess key to what we're talking about today is pairing experience design with machine learning engineering and product. We've got Shahin on the call as well. I'm one of our ML engineers. So we're talking about sort of across the business, the human and the technology needs. What we're probably going to avoid today is going too deep on data, too deep on ethics, bias, or privacy. You know, there are deep wells, deep rabbit holes where we could probably have an hour on each. And we're also probably going to avoid some of the heavier technical explanations as well. So we're talking at a sort of a product level and some of the problems that we can solve with ML and some of the problems we're solving today. So where are we at? I mean, you know, a big change. You know, we must be used to change by now. But I guess this is another big change from a technical point of view. I remember I was working agency side when the mobile revolution happened, where we went from moving from desktop only to you know, a mobile experience. We really had to rethink about how we were doing things, the work we were doing, how we were approaching it, and the context and the value of what we were doing. You know, really relearning and rethinking what we were doing. For me, I don't see any difference between the change from desktop to mobile to this new change. You know, machine learning and AI has been around, you know, since the 50s or earlier, but I guess now with the increase in computing power, businesses kind of capturing and keeping all the data on around all the customers' interactions and behavior. It kind of presents a new opportunity. The time is right. I guess what is slightly different with ML and AI versus the change from desktop to mobile is the visibility. You know, we talk about in sort of service design, the backstage, and in the background. A lot of these services and products, you know, what's happening is in the background, so it's not visible. So maybe we don't think about it. I guess going to that as well as we're probably all a little bit jaded and we take things for granted. You know, whether it's the phones in our pockets, smart devices on our desks, the cars we're looking at purchasing in the next couple of years, or you know, the vast array of entertainment options we have available to us. There is an element of machine learning in each of these, even if it's not obvious. You know, in the background, there is, you know, measurement, capture, computing, and learning happening with sort of every interaction is building a pattern from data, and that data can be used to build models, you know, enhance current features, invent new features, or you know, build completely new products. You know, talking about this the other day, you know, the visibility of this, you know, all of us would probably have smartphones here, but, you know, what Apple is doing, I think, is interesting where, you know, we have a lot of these ML services that are behind the scenes. You know, every interaction I make with my phone starts to reinforce and build the model, and they can start to predict my behavior. So something as simple as a Siri suggestion based on time, location, you know, you can present to me sort of what is being predicted that I'll need for that time and place. Credit checking and fraud, spell checking, personalized digital ads, all based around large data sets. You know, every interaction you take online as a consumer starts to build these models for both sides of the marketplace. You know, I guess most of you probably heard the cliche now, you know, data is the new oil. But I guess to intuitively understand it, you know, thinking of data as the fuel that powers your algorithm and generates results. You know, once you've decided on the objective, and which we'll talk to a little bit later, which is key. You know, you've selected your model, you've sort of analyzed the data you have based on the objective you need and the data you have. You want to be able to bring it to life. This is what we're talking about today. Ultimately, you know, the goal with all these systems is to get to a virtuous success cycle where, you know, our ML model is being reinforced by the actions triggered by the results that we're providing, and reinforcing those results to improve them and keep that they're maintained, they're accurate. You know, ML is learning from data to create answers. The more data we provide, the more accurate those answers can be. So using that sort of Netflix model, you know, as a customer, you know, who's presented with, you know, hundreds of, you know, possibly, well, thousands of options now and content, there's a human need there to be able to sort of navigate sort of what's relevant to me, what might be a good choice for my next view. You know, it's really trying to leverage data from all these past examples based on movies I've seen, you know, how you rank them. Did you even finish these movies? You can also learn from movies that other people are watching, you know, similar to age, gender, and selection as well. The more data the algorithm is able to learn from, the better suggestions you see. I guess we talked about change. We've talked about sort of these products and services that are working in the background now. You know, something that we're taking for granted. But all of this is sort of driven by change and transformation. And something that we did an event recently, Bernard Salt, author and demographer, was talking about sort of outrageous expectations. And these are being driven by digitization and digital literacy. You know, Australia has one of the highest rates of digital consumption and one of the fastest uptakes of new digital products in the world. But with each new product, it almost raises the bar. You know, we expect more. You know, with our Google phones or Apple phones, we now expect a similar level of polish and experience on all our products. So the bar is quite high. So then those expectations become, you know, to use the Fjord Designs term, they become liquid and portable. We take them from one experience to the next. So if I am being delivered sort of these tailored results by Netflix or by Apple or whoever, you know, it's easy to expect that I will receive the same experience. A little story to kind of illustrate the fact. You know, a small Scottish village that may have only ever had one post office. You know, when McDonald's comes to town with a completely different experience and level of service, that bar is then raised. You know, once McDonald's arrives, it becomes the comparison for all those similar experiences. Our expectations become outrageous and portable. So once you've experienced the convenience, the speed, the value, it's actually hard to forget. I guess through all this, you know, we're talking about machine learning, but I guess what about AI? I mean, this is the term that most people will be familiar with. We're not really talking about this today. This is kind of the broad term that describes systems capable of making certain decisions on their own. It's a very broad and nebulous term. It contains lots of things. ML is a subset of AI. Then we have sort of subsets within that as well. You know, we have AI and AI research. A lot of you probably would have been familiar with a lot of the activity that's going on at the moment in the research space with mega models such as OpenAI's GPT-3 or Meta's OPT language model. You know, these have, you know, billions of parameters sort of built into it. They are huge, flexible models, tremendously powerful, but still in that research space and not being really applied commercially. Then other ones that you might be familiar with, you know, this is the kind of hot new image generation model, DALL-E 2 or Google's Imagine. You know, these are kind of coming up quickly. You know, they're not quite ready for sort of consumer consumption. This is kind of the next big step. What we're really focusing on today is applied ML, applied machine learning, which is, you know, being able to take the machine learning techniques, you know, generating sort of answers from a large set of data to identify patterns or provide answers. And we use this to apply in sort of the products and projects we do today. I guess the point of all this is not just for large Silicon Valley startups anymore. It's possible for all organizations to create real advantage for us, a client, or a product in today's market. I guess this is where really the big change is, making things that are more accessible and more achievable than ever before. So Shahin will talk about a little bit more about this later on, about sort of things like model selection and sort of being able to kind of build a POC to kind of prove out concepts. But you know, I guess the really exciting thing is that this is not something that is kind of far off. This is actually accessible and achievable now. I guess 3 different ways ML can be used in products today to deliver competitive advantage. You can be improving an existing feature. So that could be something in a product that is already well understood. Maybe you already have customers interacting with it. You're already capturing data. And you could use ML to enhance that. Or enabling new features that you wouldn't have been able to do before. Or even enabling new products or categories that didn't exist before. So I guess improving an existing feature, using a recommendation system to personalize suggestions, rather than just on a statistical level, being able to sort of suggest as part of a larger group, but at a sort of more granular level, personalize for each individual's behavior, and then really give them tailored suggestions. Or enabling new features. We were talking about sort of something that snuck up on us, unlocking your phone with your face seamlessly, without a mask, but now with a mask. It's again quite a natural progression, but that would not have been possible without computer vision and ML. And then enabling new products completely, at the extreme end, driverless vehicles. We're not quite there yet, but things like trendy fashion search. So they're a startup where you can upload an image of an outfit that you love, and the model will analyze that and then provide suggestions that are available from different retailers, different price levels, that kind of thing. So there's a real kind of value there. And that's what we want to sort of drive towards. We want value for both sides. Using the Netflix suggestion, the human need is, what the hell do I watch next out of all this content? The business goal is, how do we increase engagement with our service? At the sort of device level, where's that app I'm looking for out of the 200 I've got installed? Like, it's a small decision, but it all adds up into a better experience. So how do we improve the experience of using our device to retain customers? There's a business goal behind all these things. Another example, with sort of grammar checkers and spell checkers that are now popping up in all the products we use. That's around typing as email is time consuming, but really we're kind of adding to that sort of virtuous success model. How do we use human interaction to reinforce our ML language model? That's kind of the business goal there. So we want sort of to be able to sort of answer the business goal and provide value there, but also answer a human need. It's not easy, but this is where we want to go with it. And this is to provide competitive advantage against other competitors who may or may not be doing the same thing. But ultimately, we want to be solving true product problems. I think this quote is interesting. So Picasso's quote is a useful lens on machine learning. An answer without a clear understanding of the question or problem that you're facing can really sort of lead you down the wrong path and lead your product astray. I guess this mindset's pretty familiar to designers and product people. We're often asked to validate a solution without a clear problem. And that's what we want to move away from. We don't want a solution looking for a problem. There's always criticism of new techniques and new technology, whether it be metaverse, blockchain, or something that's a little bit grounded and achievable like ML. We want to ground our solutions in real problems. So that's part of what we're going to talk about now. We're using this pirate metrics model. as it's useful. It's not perfect, but it sort of illustrates a range of problems that a product or company may face throughout a customer's journey, from awareness of your product or service to acquisition of their interest, to activating and onboarding them when you've convinced your consumer of the product's value, retaining that customer and making sure that they're engaged and they continue to use it. To the delight or value of your product, to be referred to friends or family. We're all familiar with NPS scores. And then finally, I guess this is one of the key ones, finally revenue and reducing costs to increase revenue once over the lifetime of the customer. So there's lots of different levels, different spaces, problem spaces for a product. And we're going to talk to some of these with some of the case studies we've got next. But where machine learning, I think these are just examples where machine learning can kind of help. At the acquisition stage, digital advertising and segmentation is already happening at that acquisition level. Large models, really trying to personalize ads and target them. The old world of advertising has been blown apart by this. You can be more targeted than ever before. At the activation level, personalizing an offer for a customer and then being able to onboard them, through retention, sort of predicting and being ahead of a customer's needs and being able to enhance their experience. Referral, this talks to their holistic experience overall, and then revenue, sort of streamlining and automating. So I guess what are the elements that we're talking to with all these? We talk about a business goal. Obviously for us as consultants, you ultimately want to be providing value for our client or our customer. But there needs to be something that makes this solution viable long term. But really, we want to focus on user outcomes, the human problem. We want to drive business by helping users achieve their goals. We have to understand those goals. And that may be through existing data or through research. Being able to sort of frame that problem is the ultimate goal. We want a range of ideas and solutions. We don't want to be restricted to machine learning. We want to be able to look at a range of ideas and then assess those ideas for best fit. And I guess something that is really is particular to machine learning is being able to narrow down on a specific solution and then create a machine learning objective. Now, this objective is really key. This kind of frames the whole next stage of, once we have our objective, we can start to prototype and build a proof of concept and sort of prove that the solution is actually feasible. So, and this is part of a sort of a cross-functional ML team. We want to be able to choose the right objective for the right algorithm. It's one of the most important jobs we have. It's also one of the hardest to get right. Knowing what you want your algorithm to accomplish is important because we're not talking about a broad range of capabilities. We really need to sort of focus down on one particular action or task. If we oversimplify it, that could be too broad and we won't be able to provide the answer that is narrow enough or useful enough. Or if it's too narrow, maybe it doesn't allow for enough sort of variance. Our objective will start to dictate our model selection, the type of data we need, and the type of answer we're looking for. That could be a yes/no answer, a cat or a dog, damaged or not, Tom or Shahin, or a number or value, a house value, a salary range, or an estimated age, these kind of things. I think we talk about thinking fast and slow. We guess what we want to use our intuition first. come up with something we think is going to work, and then experiment through prototyping and iteratively improve our results. So into some examples here. So Digital Wellness is a client we've been working with for a while now. You know, they're a leading global business in the health and wellbeing space. They've had great success with delivering digital programs for weight loss with the CSIRO and the Mayo Clinic in the US. But I guess their particular problem was around, you know, retaining and retention of customers. You know, in the programs that they have, the first 12 weeks are vital to kind of build habits, but they're also the hardest, you know, because I guess all of us who've done a diet or tried to stick to anything, if you're not seeing results, it can be quite discouraging. And ultimately, without that retention, that was going to impact revenue. And also with the, you know, with good weight loss and a good experience, they want continued referral. So I guess these problems, it could be a range of problems that we're talking to. So I guess the business goal that they were trying to achieve, sort of, you know, to improve member engagement in the first few weeks of their 12-week program, to reduce churn and increase revenue. From a human point of view, losing weight can be incredibly difficult. It's easy to get discouraged and give up if I'm not seeing the results I'm expecting. The solution that was settled on was to be able to set reasonable weight loss targets and show members personalized messaging and weekly progress to encourage them to continue. So to be able to coach them through. And the objective that we wanted to achieve was, or the answer that we wanted to get to, like, what is the predicted weight loss for a member by the end of that 12-week program? So we're setting targets and goals for them to be able to sort of head towards. And this is where it gets really interesting because, you know, we can answer our objective. You know, there's a massive sort of technical engineering challenge there, the right data to get to the right answer. But then we also need to sort of frame the result as well. You know, and framing these ML results is a key experience design challenge because, you know, we can't predict with 100% confidence, and oftentimes we need to provide a range or with an amount of variability. So for this particular customer, you know, it's predicted that their super focused target, if they do everything right, they do exactly the amount of exercise that they need to, you know, it's predicted here that they will have a weight loss of 8 kilos based on their age, sex, habits, calorie intake, etc. But a more reasonable target is 5.5 kilos. So being able to sort of frame those results as sort of a range makes it, you know, easier to be able to surface that answer, but also kind of set the expectations as well. We also need to explain how those targets work and how that is derived. So, you know, we could predict the weight loss over a 12-week period, and then weekly we could tailor the messages given by Hope, who's our AI assistant, AI coach, to continue to provide encouragement as well. So, you know, building that retention in and building that encouragement so people don't drop off. So I guess the next one we're talking about is sort of a leading accommodation website, and their key problem was around sort of acquisition and then driving through to revenue. I know all of us who've booked hotels, it's pretty common that, you know, people won't be browsing across one site but multiple sites, and really comparing and contrasting which site is offering free breakfast, who's a few dollars cheaper. You know, it's easy to get kind of overwhelmed with options. But they wanted to lift their conversion rate and drive more bookings. I guess the key challenge with this with a lot of those hotel sites, they're actually often asking you to be logged in, or with Netflix or Amazon providing recommendations based on your logged in data. Whereas this one, we were being asked to sort of surface predictions on hotels that might be relevant without a logged in profile. So based on sort of data across websites, we could surface better results. So again, the business goal, increasing hotel bookings with customers that are not logged in. The human problem is, I want to book a hotel, but there's so many options to choose from on all the sites that I'm looking at. The chosen solution was, a custom recommendation system to cluster properties and classify queries to identify which hotels to show on the first page of results. And the objective, the ML objective, is for a given customer and their search query, can we recommend hotels they are likely to book? So trying to predict what is attractive, what is interesting, what is going to drive that sale. So the model was built, the system was created. It resulted in a marked improvement with 50% of bookings. The chosen hotel was recommended to the user on the first page of the search results. So, going from a sort of traditional recommendation that was probably based on broader statistics to an ML recommendation, which is more granular, maybe not personalized to the sort of individual that we might be able to do with a logged in, but a lot more granular and a lot more targeted. Third example, so Bolttech, we've been working with them for a couple of years now. An international insurtech company, with the mission to build the world's leading technology-enabled ecosystem for protection and insurance. So they're trying to do things differently. They're trying to differentiate themselves from others in the market. We know there's a lot of different insurance providers out there. I guess for them, their problems are really in sort of the acquisition and activation space, getting people interested in their product, having a point of difference, and then streamlining that process and being able to sort of get them on board. So I guess the business goal, automating that assessment for screen protection. We're talking about sort of mobile phones here and being able to assess whether they're damaged or not. And this is to replace a slow manual process. The human problem, I want screen protection insurance for my, increasingly expensive device, but physical inspection of my smartphone is inconvenient and slow, and I want coverage quickly. I need it here and now, rather than in a couple of weeks. The longer I wait, the more chance that I can drop my phone. The chosen solution was to guide the user to take a photo of their smartphone in a mirror with their own smartphone through the app and use computer vision to assess the condition of the phone and to automate that insurance approval. So we're really trying to streamline it and sort of make it as easy as possible. But the objective is, based on that photo of the screen, to classify whether the smartphone is damaged or not damaged. We're getting to that sort of yes or no example. This was interesting because there was actually multiple models applied to be able to solve this. The first model is there to detect whether there is actually a phone in focus or not, and assist with positioning it into the right angle, the right place, to really be able to sort of take a good photo. And that was optimized to run on the smartphone. We call that sort of an edge model. We're not sending off to the cloud. We're doing it on device. And the second model was the classification of the screen. So categorizing as cracked or not cracked. That model was a lot more complex. So that's hosted on the cloud. So there's a delay once that photo has been taken for that classification to happen, and then sort of come back and approve or not approve the customer. Again, like there is a key experience a challenge there as well. You know, guiding the user to take the right photo in the right way, position it on screen, you know, to be able to set the kind of set the context that the machine learning model needs, you know, to get a good photo, to make a good judgment call on whether the screen is cracked or not. It's a lot harder than it seems. So I guess those are 3 different examples of some problems that we've solved with clients and customers. But now we're sort of getting into sort of the how of this and how we kind of get started and what we need to look out for. So this, you know, we're really talking about sort of bringing our idea to life. You know, going from a problem and a set of ideas to understand those problems, you know, pick the right one, pick the right solution for a good sort of machine learning fit and the data set we have available, into building a POC or a prototype, you know, experimenting with different models, different ways of achieving that objective and iterating on that. You know, this is, you know, an agile process is key to this and key to everything we do. There's an iterative process for all of this. Ultimately, when we've kind of reached the threshold that we're comfortable with, accuracy of results, we can start to think about sort of going into production. You know, we need to sort of build, we need to productionize. You know, building a POC is very different to getting something out the door. It takes a sort of a different level of systems and different levels of productionization. You know, around data infrastructure and pipelines to be able to sort of deploy models at a large scale and sort of launch into MVP. And finally, you know, we talk about sort of continuous discovery, but this also applies to, you know, launching one of these products into the market. Monitoring performance, retraining with new data to reinforce sort of the results that we're already getting, you know, managing versions, possibly swapping out for something that is going to work better. You know, there's a constant cycle of assessment. We don't just build something once, we continually sort of improve and iterate and redeploy. I guess we get into sort of choosing the right problem. This is a key one. It kind of sets the scene for everything we do to be able to sort of, you know, come up with a range of solutions and, you know, sorry, come up with a range of solutions and be able to get to the right one that's going to have the right impact. It's always better to start with the least complex problem, you know, and also assessing the data that is available is a key part of that complexity assessment as well. I heard something this morning, you know, simple scales and fancy fails. This is something that sort of applies to doing this work more than ever. So we want to start with something simple that we can sort of demonstrate easily with a POC and sort of build iteratively and improve. We also want to evaluate the ideas that we have come up with. We want to assess a broad range of solutions for fit. You know, we talk about shift left, you know, sort of shifting that risk earlier. We want to be assessing that risk as early as possible to be able to get the best result. And we do that in a variety of ways, by having a mix of ideas and assessing for fit, by having a mixed team and having a cross-functional view, looking at the sort of human point of view, the business point of view, and the technical point of view. And that is where we sort of need a diverse range of specialists as well, whether it's experience design, product, ML engineering, or a data engineer. You know, there is a sort of a group there that's needed to achieve this. One of the things we're also looking at early is we want to sort of think about sort of risk or impact. You know, we said we weren't going to get into ethics or privacy today, but I think some of you probably saw yesterday a perfect example of the impact an ML solution can have on a brand in the public domain. I guess to note, every ML solution has some risk inherently, you know, because they are slightly open-ended. And we're also using the data that could be public or private. I mean, in this case, the retailer did the right thing, informed customers of the use of facial recognition. But I guess the other side of that, and something we want to be thinking about early, is AI and ML is still seen as the boogeyman by the media in many cases. So we want to be thinking about the impact of this as early as possible. You know, what happens if the model starts to drift? You know, constantly monitoring the sort of results that we're getting to make sure that they are as accurate as possible. What happens if bias starts to appear in our results? What would public sentiment be if we don't communicate its use? Could it be used for negative purposes? And what's the perception of the value being created? And I think this goes back to sort of the outrageous expectations we talked about earlier. You know, there's almost a trade-off there for you know, every bit of data that is being used, that we are creating through our interactions and behavior. We need to kind of balance that with sort of value for the customer. So I'm going to hand over to Shahin now, and he's going to talk about sort of more of the engineering side.
Sure. Hi, everyone. I'm Shahin Namin, one of the machine learning consultants at DiUS. And for the rest of the talk, we will be looking into what a machine learning specialist is dealing with in a real machine learning project. So when we start to look into a machine learning problem, and assuming that the objectives are defined and we know the KPIs and what performance level we are looking into, we have a few different options. We can start with machine learning as a service, which are tools that are available on the cloud, provided by the cloud providers. They are usually very, very easy to use. They require zero to very little knowledge of machine learning, and they are very fast to use. It's very easy to use them, but the problem is that usually these models and services are generic services, so you won't be able to get good performance for your specific problem. The next option is an AutoML tool, which are again available on the cloud, and also there are open source options for this. So in this case, you try to pass your data to a tool like an AutoML tool, and you ask the tool to abstract away lots of machine learning complexities from you, and it goes and trains a model and gives you the model. Obviously, you need to have a bit of knowledge of machine learning, but this is not the best performance you can get, because if you have the right amount of knowledge on the machine learning expertise, you can go and create your own model. You can use state-of-the-art models, but in that scenario, you have to know machine learning really well enough. The amount of effort is really high, but at the end of the day, you end up getting a good model which is specifically designed for your own problem, trained on your data, and hopefully it will be able to give you enough performance for your problem. But obviously, the amount of effort is a lot higher. Next slide, please. So when it comes to a proof of concept, it's an iterative process. What we usually do is that we define a time-boxed approach, usually 4 to 6 weeks. And in that 4 to 6 weeks, a machine learning specialist will go through a set of steps. So we get the data, we try to analyze the data and come up with the right features and input to the model. We choose the right model. It might be a state-of-the-art model, or it might be a mature model for your problem. We try to train your model on the data that you have, and then we will evaluate and see where we are at. So this is an iterative process. You need to go through these again and again until you get to the point where you are happy with your model. But basically, there are two ways that you can iterate on this. The first approach is to go through this again and again. Consider that your data set is fixed. You go and try to come up with a better model that works on your data. And this is usually within the scope of a proof of concept. But beyond the proof of concept, what we do is that we look a lot more closely into the data and into the model. We try to find the scenarios where the model is not giving us good results, and we go and start to collect or generate synthetic data that covers those scenarios where the model doesn't work. This is usually a longer term iteration. Sometimes you go and implement your solution end to end, and then you iterate and try to collect more data and basically improve your model that way. Next slide, please. So after a proof of concept, we try to productionize the model. Obviously, in proof of concept, what we were trying to achieve was a model that is performant enough. So the feasibility of the model was the issue. But there are other aspects of the model that we need to take into consideration. As an example, when a model is ready and it is workable and we are happy with the performance and accuracy of the model, we have to try to go and basically host that model on the cloud or maybe on the edge or any device. So there are decisions that we have to make on the infrastructure. We have to make sure that we are not choosing a very expensive option for infrastructure, but at the same time, we need to reach a specific latency and throughput. So we need to make sure that our model is responsive and it can respond rapidly to the requests. In addition to that, we try to work on automation of the model and its retraining. So basically, the first proof of concept was a set of manual steps that we went through again and again. But here we try to automate that step by implementing pipelines that allow us to train the model and host that model end-to-end using that pipeline. After that step, we try to integrate that with a continuous integration and continuous delivery pipeline. And that allows a data scientist to work on the model or whenever that the data is available with a single click or with a commit on the code repository. The whole pipeline is automated and it starts running. It trains the model. It compares the model with the previous model that is already in production. And if the model is working better than the model that is in production, we can go and replace that, provided that we have confirmation from the right stakeholders. So that's a set of steps that we need to follow. And usually it's a gradual process. So it takes time. And the aim is to basically make the life of a data scientist a lot easier so that they can run the whole retraining and creating a new model in a frictionless manner. When it comes to practical problems, sometimes what we do is that we try to roll out our model gradually. And that means when we start a machine learning project, we have a process that a person is involved. They are actually processing their data and they are coming up with their judgment. But gradually, you try to replace that judgment by a machine learning. So this is a gradual process. Sometimes you start with the model in parallel to the people in charge. you try to compare the results, and gradually you try to gain confidence in the model. And when you feel more confident in your model, you can gradually increase the requests and the volume of requests that are sent to your model until it is fully automated. When we have a model in production, we need to make sure that we have monitoring in place. This is because although the model has been working fine and we have confidence in that model, things might go wrong. And as time passes by, we might see that the performance of the model decreases for different reasons. It might be that the data and statistics of the data is changing, or the model has drifted. So we just have to make sure that we have monitoring in place so that we have health checks, and basically that monitoring can trigger the next round of retraining in case things go wrong. Next slide, please. There are different applications of machine learning where we are dealing with a very sensitive problem. So we can't really afford to have a mistake in the output of the model, because that might be very costly and catastrophic. As an example, if you think that a machine learning is going to predict the credit worthiness of a person to get a loan, this is something that you don't want to make any mistakes, because you might give the loan to a wrong person, or you might basically reject someone who is totally legitimate to get a loan. Another example is the insurance, the Boltec project that we had the human in the loop in there. But what the pipeline looks like in these scenarios is that we add the human reviews and intervention in the process. So the data comes in, it hits a model, we get the predictions and outputs of the model. For the scenarios where the model is not certain, we pass the data to a human as well as the prediction of the model, and the person will either reject or accept the model predictions, and the person might correct that actually. So this has two benefits for us. Firstly, because we are making judgments by a person, basically we are labeling the data, so we will store that data, and that data can be used for further retraining of the model in scenarios where the model is not performant enough and is not giving us the right answer. And in addition to that, we are actually de-risking the machine learning projects, and we are minimizing the consequences of a wrong prediction from the model. So this is a loop that for some specific projects we might implement. As you can see, there are human interventions here. A human is involved in the whole process, but gradually as we gain more confidence in the model, we will try to decrease and ultimately remove the intervention by a human. And with that, I pass it back to Tom.
Thanks, Shahin. So what we've talked about here is sort of end-to-end. One of the key things is sort of evaluating and assessing all the way through, proving that solution is viable and is going to do what we need it to, as well as reducing risk. From the very beginning of that problem, where the problem and idea is, all the way through to launching and monitoring that solution. So to wrap up, I know we've only got a few minutes left and we've got a few questions. What we're talking about here today is, the ability to differentiate the product. As we've talked about sort of with ML, it is achievable now. This is not something sort of out of the bounds of sort of smaller organizations. It can be really targeted around sort of key product problems. We also need to pick the right problem to be able to solve it effectively. Understanding the value that ML brings is really important. We sort of can't embark on sort of any sort of project or any kind of piece of work without understanding how it works in some sense. And we can solve different product problems at different stages through that customer life cycle. And I think we're handing over to Mark.
Thanks, Tom and Shahin. So how can DiUS support you on your machine learning journey? Show there's ambulance behind there. We heard about how machine learning can help you, I guess, improve your product and the importance of picking the right problems to solve. If this is your first foray into machine learning, it could be quite difficult to know where to start and how to get started. We'd like to offer you a complimentary workshop with our team to understand your specific business needs, challenges, and opportunities. Perhaps use the funnel, I should say, Tom presented earlier for inspiration, and determine where machine learning might be suitable for your situation. Alternatively, we've also found that some organizations who have started on their journey might not be getting the results or the accuracy needed. So we can help with strategies to improve them. Shahin mentioned both data-centric and model-centric approaches earlier. So the workshop can be tailored to focus more on improving existing products. The QR code's over there. Next slide quickly, Tom, if you don't mind. We mentioned earlier also that the machine learning survey, the national survey we conducted last year, and how insightful that was for us to get insights, I guess, and a sense of ML adoption locally here in Australia. We've just launched the survey for 2022. Irrespective of where you are on your journey, whether you've started or not, we'd love for you to participate this year. We plan to share our findings in the next couple of months, and all participants will get a copy of that report as well. So absolutely encourage you to participate. That's the end of the prepared presentation. We might actually flip over to the questions really quickly. And we do have one here from Kanal. Thanks, Kanal. And the question is, what criteria would you consider to decide where buying an out-of-the-box solution is better than building your own, or vice versa, i.e. buy versus? But that's a common question we ask. I think Shahin touched on some of that earlier, but it really depends on the context of your business situation. If an out-of-the-box solution works for your problem, then by all means use it, especially if it's not something that or applied in an area that really differentiates your business, or you might not even have the right skills in your organizations yet to build your own. Many of those out-of-the-box solutions are great to get started, but as Shahin mentioned, it can be difficult to, I guess, tailor it, enhance it based on your own unique needs. And they might also lock into a particular deployment architecture that might not be right for you. So I guess some of the quick things you might think about include, do you have the in-house skills? How unique is your problem? Does the ability to tailor that provide you a competitive advantage? Are there any limitations with those pre-built services around, in particular, deployment? Does it have to exist on the cloud? You might have some needs around connectivity, response times, or the need to deploy your model solution on device. We didn't cover some of the scenarios where we've done that, but Edge ML is a growing application area, and of course, there's always the cost consideration as well. What I guess we find is organizations might use out-of-the-box solutions in some scenarios or some problems and go custom for others, or even a combination of both. Looking at the questions, that looks like that's the only one, and we might close really quickly. I just noticed Matt Bettina. I just noticed your message on the chat. Thanks for your feedback. We know it's quite late in the US, so hopefully we haven't kept you up too late. We certainly appreciate you joining us. Thanks again to everyone for joining us. Again, we'll make the presentation available to you. We do encourage you to take advantage of the workshop and also participate in the survey. Thanks again, and looking forward to picking up the conversation with each of you moving forward.
Thanks, folks.